Hi, thanks for joining me for this video. We're going to be talking about the measures of central tendency. I would say most people are familiar with these, the mean, median, and mode. It's how to kind of measure the middle of a data set. So the mean of a set of data is the sum of the data values divided by the number of values that you have. It's commonly called the average. So when you think about your grade in most classes, it's usually some kind of an average or a weighted average system where you can add up all your scores, like let's say your test scores, you add them all up and divide them by the number of tests, and you would get your average, your test average for that class. The median is the middle value of a data set. So the data set would be in order from least to greatest, and you would just pick out the middle number. If there is an odd number of values in your data set, there is a middle number and you would just choose that one. However, if there's an even number of data values in your set, then the median is found by finding the two middle values and you just take the mean of those two. Finally, the mode of the set of data is the value that occurs the most often. So if you have a number that keeps repeating in your data more than any other number, that's going to be the mode of the data set. So let's look at some examples. Number one, you recorded the time in seconds that it took for 8 participants to solve a puzzle. The times were as follows. We want to find the mean, the median, and the mode of the data set. So the first thing you want to do is look at the data set to see if it's ordered from least to greatest. If it's not, you're going to reorder it. So it looks like this one is already in order, so that's good. So the mean, we simply need to add all of those up and then divide by 8 since there are 8 participants. So 15.2 plus 18.8 plus 19.3 plus 19.7 plus 20.2 plus 21.8 plus 22.1 plus 29.4 divided by 8. So when I added up all of those values, I got 166.5, and then I'm going to divide that by 8, and I got 20.8 rounded to the nearest tenth. I decided to round to the nearest tenth because that's what all the values were rounded to. So the average would be 20.8 seconds. So that is the mean. So again, the mean you find by adding up all the data values and dividing it by the number of data values you have. Part B is find the median. So for the median, we're just looking for the middle number. What I find easiest to do is to cross off the lowest and the highest. Lowest, highest, lowest, highest, until you get to the middle. Notice I have 2 values left. Here are our 2 middle numbers. And so to find the median, if you have an even number of items, which we do here, you add those 2 middle ones up, so 19.7 plus 20.2, and divide it by 2. So you're finding the mean, or the average, of those middle 2. So when I added those up, I got 39.9, and when I divide that by 2, I'm going to get 19.95, so rounded to the nearest tenth, I would get 20.0. So that would be my median. Notice that the mean and the median are not the same, so these values could all be different. Finally, I want to find the mode. So the mode is going to be the number that appears the most often. In our case, we don't have any repeated values. They're all different. So you could just say that there is no mode. Let's look at number 2. So number 2, a group of individuals listed the pets that they currently have in their home. The responses have been given in the table below. Find the mode. So we want to find the one that appears the most often. So let's see. 1, 2, 3, 4, 5, 6, 7. It looks like dogs is 7. Cats, 1, 2, 3, 4. So cat is 4. Fish is 2. And hamster is 1. So dog appears the most, so that's the mode. So dog is the mode. Why is the mode the best measure of center for this data set? So for the mean and the median, you can't say there are, partial dogs, right? The median is the middle number. You can't put these in order from least to greatest because they don't have value. You can't say a dog is worth more than a fish or vice versa. So median and mean are really used for numerical data. The mode would be the best kind of measure of central tendency because it measures what happens the most often. So that's the one that's going to make sense for categorical data. So the mode is the best measure of center for this data set because the variable is categorical, not numerical. All right, number 3. The 100 families in a particular neighborhood are asked their annual household income to the nearest $5,000. The results are summarized in a frequency table below. So we want to use this table to find the mean, the median, and the mode. So to find the mean, we have to add up all 100 values, and even though it doesn't maybe look like 100 values, notice that the frequency is used. So the income in thousands of dollars, this first row means that 6 people recorded or reported income of $15,000. So if I was going to list this out, it would be 15,000, then another 15,000, then another 15,000, and I would have to list this out 6 times. Okay, then I would have to do the same thing for the next row. 20,000 would have to be listed 8 times. And then the next row, 25,000 would have to be listed 11 times, and so forth. That takes up a lot of space and a lot of time to write it all down. It's much easier to use this frequency table where you're just saying, hey, 6 people said $15,000. 19 people said $35,000. So when you have a large data set, this frequency chart really comes in handy rather than listing out every single response. To find the mean, we should technically add up all of the data and then divide by however many data values we have, which is 100 in this case. To make it easier, what you want to do is multiply your income times the frequency. So 15 times 6, and you will get 90. And this is going to be in thousands of dollars. So this is going to give you, it's just a quick way to add it all up. So since there were 6 $15,000, if you add up 15,000 6 times, you would get 90,000. So 20,000 appears 8 times. So if you multiply that, you'll get 160. 25 times 11, 275. 30 times 17 is 510. 35 times 19 is 665. 40 times 20 is 800. 45 times 12 is 540. And let's see, 50 times 7 is 350. Okay, so now we're going to add up everything in red. So we're going to add all of those up. When I added them all up, I got 3,390. So once you do that, you can now take that and divide it by n, which is the number of data points in your data set. So to find the mean, we're going to do 3,390 divided by 100, and we will get 33.9. Now the mean, remember this is thousands of dollars. So it really means $33,900 is the mean income of this neighborhood. Now we want to find the median. So the median is a little bit tricky when you have a chart. If you have 100 items, what you want to do is find the middle. So 100 divided by 2, because you have 100 items, you want to find the middle, is 50. If you have an even number of items, let me just scroll up real quick to look at the previous one. Oh, that messed everything up. Okay, let me not scroll up. So in the previous example, we had 8, or actually it might have been the first example. We had 8 things that we were trying to find the mean, median, and mode for, and we ended up boxing in numbers 4 and 5, and then we had to find the middle. So whenever you have an even number of items, you're going to have to take the middle 2 and average them out. So I'm going to be looking for 50 and 51. So I'm going to be looking for data values 50 and 51. So I'm going to have to figure out where they land here. So that is going to be, what I'm going to do is start adding these frequencies up. So 6 plus 8 is 14. 14 plus 11 is 25. 25 plus 17 is 42. Okay, 42 plus 19 is 61. Okay, so that means that I'm adding these up. This is called a cumulative frequency. So maybe I should make a new column. So the cumulative frequency is what you get when you add up as you go. So 6 plus 8 is 14. 14 plus 11 is 25. 25 plus 17 is next, is 42. 42 plus 19 is 61. 61 plus 20 is 81. 81 plus 12 is 93. Oops. And 93 plus 7 is 100. Whenever you're doing the cumulative frequency, you just keep adding as you go down the frequency column, and at the very end you should have 100. So that tells you your first or smallest 6 data points are in the first category, 15,000. Then your next, like items 7 through 14 are 20,000. Items 15 through 25 are 25,000, etc. So we're looking for items 50 and 51. So 50 and 51 are going to have to be in this one, because this one says that items 43 through 61 are 35,000. So that means 50 and 51 are both 35,000. So 35 plus 35 divided by 2, that's going to be 70 divided by 2, which is going to be 35. Now, it should be no surprise if you're adding the same thing and dividing by 2, you're going to get what you had. So $35,000 is the median. Finally, we want to find the mode. So the mode is the number that appears the most often. So we're just going to look down the frequency column, and we'll see that 20 is the highest number in the frequency column. So 40,000 will be the mode because that's the one that appears, the most often. Okay, let's look at number 4. Yep, that's our final example. By the way, these examples and the information was taken from a free online textbook by Scottsdale Community College. It's called College Mathematics, the first edition. If you're interested in getting some more examples, that's a good resource. So the final example, suppose that in a small town of 50 people, one person earns $5 million per year and the other 49 people each earn $30,000. Calculate both the mean and the median, which is the better measure of the center. Okay, so the mean, we have to add up all of these values. So one person earns 5 million and 49 people earn 30,000. So I'm going to be adding 30,000 up 49 times. In other words, 49 times 30,000. So that will be 1,470,000. Notice that all 49 people combined do not make as much as that first person. And now I'm going to be dividing this by 50 because there are 50 people in the data set. Okay. So the mean is $129,400. So if all you knew was the mayor, let's say the mayor is trying to get people to move to his town, and he's like, hey, the mean income of our town is $129,000. Then you're thinking, oh, the average income is $129,000. Well, that's a great place to move because the average person makes that much money. But if you see the actual data, it's very misleading. Everyone except one person only earns $30,000 a year, and one person earns $5 million. The $5 million is really pulling that average way up. If we left him off, then the average would just be 30,000. So one extreme value, either extremely high or extremely low, will really pull the mean toward that extreme value. So that's important to keep in mind. Next, we want to find the median. So the median will be the middle. Since they're all 30,000 except the 5 million, the median is definitely going to be 30,000. So if the mayor said, hey, the median household income is 30,000, that's actually a very good representation because, again, everyone except the one person makes $30,000 a year. So in this case, the better measure of the center would be the median.